So welcome back, everyone, to this session on Modulithic applications with Spring Boot. My name is Oliver Drotbohm. I'm working for a company called Pivotal. Probably heard of that one. I spent a lot of time in the Spring Data team for, well, half a decade to a decade, leading the Spring Data projects, and just have recently intensified kind of the work on the, as I call it, architecture-evident parts of the Spring Data side of things. So event publication, the role of repositories in an application, and what have you. So this is sort of where this talk is coming from. So you can't actually attend a conference these days without hearing about like microservices, and like you can get the impression that you actually have to implement every system out there using microservices, right? And of course, the world's not black and white here. There is different use cases and different scenarios where like a slightly more monolithic approach might make more sense than starting off with 20 different systems in the first place, right? And just to give us a common ground, what we're talking about here. So the primary difference being that within a monolith, the bounded context or logical modules being all part of a single deployment unit that interact within the same JVM. Microservices deployment basically accepts that the deployment boundaries sort of equal the bounded context boundaries, and we, instead of having a local interaction, we have remote interaction, right? Whether it's through a message broker, whether it's through REST APIs, or what have you. If you're interested in a more detailed discussion of like benefits and drawbacks, there is another talk I've given, I think 1 or 2 years ago at Spring One, refactoring to a system of systems. That's actually, if you're interested in that, have a look. There's a couple of recordings, also the one from Spring One. There's a couple of benefits to starting monolithic. First one is easy to refactor, right? Especially if you're in a domain that is which you're not really sure in which you're not really sure about the actual boundaries of your bounded context, then it's much easier to just be able to use your IDE and your refactoring tooling to just move code around, right? That functionality that started here over on the left is now actually better placed on somewhere on the right. And with a microservices arrangement, you'd have to sort of evolve APIs, convince other teams, right? Often it's not even a technical problem, but more of an organizational one, that they have to change things, or we want to change things, and then others have to adapt. That's much easier if like all the code is part of a single code base. It's also pretty easy, especially using Spring Boot and in general the Spring Test Context framework, to just run the entire application, right? You have at Spring Boot test annotation, and you bootstrap the application context, and all the components are wired up, and if something's like miswired, then the application context start fails, and you can investigate, and you can just like work with the thing, right? The problem, or I mean, why are people? I mean, if this is all good, why do we even like think about moving away from monolithic scenarios? So one of the issues I've seen is, or in almost every monolithic project I have seen so far, is that without explicit management of the dependencies between the logical modules, the structure of the monolith is very likely to degrade, right? So it's kind of like some new developer comes onto the team, doesn't really know about like the intended structure, and then needs to reuse some functionality from over there, and then, as I call it, the architectural violation is just an auto-wired away, right? So you can just like auto-wire yada 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 some other component from some other part of the system, and you've created the dependency that might be troublesome if you later want to change something. It's also harder to test like individual parts of that monolith, and that's actually even something I've heard quite repeatedly, why people start with microservices, because they want to be able to test the inventory system of their e-commerce system individually, right? So they don't want to start the bootstrap the entire system in the first place. With microservices, just to recap, I'm just trying to focus on the things that are important for the context of this talk here. With microservices, the switching from local to remote interaction opens a entirely new can of worms of problems that you then have to take care of, right? There's an entire network in between, so the invocations become, of course, much slower. You have to serialize and deserialize objects. The network can become fragmented. The other system might be slow. The other system might not answer, which sort of is the same at some point, right? So there's a ton of new problems that you might just not want to deal with in the first place, right? Testing individual modules, as I said, is something I hear as a reason for moving to microservices a lot. However, it's not without problems either on that side of the spectrum, especially if you're not. I mean, you're using synchronous remote invocations a lot. Then testing the individual module requires you to either run the collaborating systems or at least stubs of those, right? And that's kind of can become quite problematic as well. You have to use wire mock or whatever to mock out these APIs and what have you. So a system that's generally interacting a lot with its environment is kind of hard to test in the first place, right? So you should probably try to avoid that. Again, this is something the other talk is going into much more detail. Harder to refactor the context boundaries, mentioned that before. And it's even hard to test the system overall because, I mean, if you have a couple of different services which you need to fulfill some use case of a let's say of a purchase in an e-commerce system, then you need to run 2 or 3 systems and then gather information from all of them of whether they work correctly. So it's again quite a bit of infrastructure to set up. All right, so before we start with what I'd like to tell you, or what I'd like to show to you, some R&D work we've done here, there's a sample code base that you can inspect and that I'm going to work with throughout the example that I've worked on in collaboration with the University of Dresden in Germany. And they do a fun thing. They have third semester students who have had half a semester of Java, right? So they barely know what an annotation is. And then on fourth semester, they are tasked to write a web application using Spring Boot, which is kind of a fun experience to watch that, right? It's, but it's actually, I started getting involved in this project when Spring Boot was quite young, and these very, let's say, novice views on web application development, and those people coming along without any prejudice or whatever, has actually even shaped a couple of Boot features, right? So there is the underlying bits of this project they have to do, because we can't really let them learn JPA and Spring MVC in the first place. There is some kind of library underneath their project called SalesPoint, and it contains literally everything up to the service layer for a standard e-commerce application, right? There's a catalog with products, there's orders that you can place to order products, and there's an inventory system that basically keeps track of the stock of the individual products. And there's a bit more stuff in there. I just wanted to give you an impression on what this kind of stuff is doing. We're focusing on that part to give you an idea of what I'm going to go on with. The thing is that the library itself, SalesPoint, is a monolithic jar. We can have a quick look on that. Just an Eclipse project here, or a standard Maven project. You see, you find these individual packages for basically abstracting or encapsulating the modules. So there is some kind of intended architecture, and which means between those packages there are allowed dependencies and non-allowed dependencies, right? And the question is, I mean, I could go ahead and basically show you the entire architectural diagram, which sort of I already did for that for those 4 modules. But the question is, okay, how do we actually maintain or monitor the structure and avoid that someone comes along, me maybe, and just introduces some dependency that we don't want to avoid the degradation, basically, right? All right. So along comes, as I said, the R&D work that we're doing here. A project called, for the lack of a better name, I just called Moduliths in the first place. It's still my personal GitHub account. I'm not sure it's ever going to make it into the official Spring Projects thing, because it's quite an opinionated way of thinking about like the structure of a monolith. And I would like to basically show you the ideas behind the thing, what we're doing with it, and how it actually plugs into Spring Boot and can help your Spring Boot application to maybe stay more structured. So the fundamental thing we start with is a convention to map bounded contexts to packages. You've seen that probably already, right? So I had the catalog module, that was a catalog package. I had an order module, it was an order package. So the idea is, first and foremost, that for a start, unless things get terribly complex, and we get to that later on, try to stick to like business level packages. So no domain package, no repository package, no service package. I mean, we all know, we've all been taught layered architecture in university, right? And if you look into a package and you find an order repository and an order service, you know what's going on, right? There's no need to actually really transport that on the package level. There's a couple of advantages that has, that reduction of packages. I'll get to that in a second. So structurally, what I'm trying to say is, yeah, you have your Spring Boot or whatever yada yada application class in your root package anyway, and then start with packages for each of the top level modules right underneath. The approach has the advantage that you can basically, as I said, the primary danger for architectural violations usually is that someone auto-wires or dependency injects something that he or she is not supposed to, right? And the easiest way to prevent that is to avoid a ton of public types in your system, because if a type in a package is public, it can be referred to from everywhere. So if you can actually get your package layout to support the aspect of being able to make types package private, then that's kind of helpful, right? Because there's less of a chance to actually introduce a violation. So if you, let's say module A is catalog, module B is order, you can have your service types public, but the repositories package protected, so that no one from the outside can even auto-wire things, because the compiler already would reject that. Okay. So, that's kind of the first bullet point is kind of the prerequisite for everything that's now following. So, let's say there was some technology that would, if you opted into that package convention, could actually use that for good. Then that's actually what you get with point 2. So test support for individual module Bootstrap. Who of you has been to Andy's talk on testing Spring Boot applications? Not too many. Highly recommend it. And I'm asking because there seems to be a Spring Boot feature that's pretty, or at least in the other talk when he asked for how many people know about this feature, only a few hands went up. This test slice support, has anyone heard about that? So you can tell Spring Boot to only partially bootstrap your Spring Boot application. And the aspects that Spring Boot ships are, or basically the criteria in which Spring Boot provided test support for that is horizontal layers, right? So there is a data JPA test annotation that will bootstrap only Spring Data JPA repositories. Or there's an add web MVC or add webflux test annotation that will only bootstrap the web layer of your application, so that you then have to mock, let's say, your service components or all the dependencies of your controllers, and then you can only test the the annotation. And the question I had, or asked myself basically, was if that's possible, like on the horizontal level, why shouldn't I be able to do exactly the same thing for the vertical slices, right? So for business slices, basically. Because, I mean, I understand that Spring Boot cannot ship that out of the box because there's no way for it to identify module A and module B. And I guess you know where I'm going with this, right? If we agree on that package convention, we actually can. So with Moduliths, the way that Moduliths actually interacts with your Spring application in the first place is not at all. Because at runtime, when you run your application, it still adds Spring Boot application. It doesn't change a thing about like the actual production usage of your application, which is, I mean, it was supposed to be. I started with the assumption or the hope that I could get it as non-invasive as possible. The thing that you get is an additional test annotation in the first place that says add module test, and by that test being located in one of those module packages, it would go ahead and during the application context, Bootstrap will limit all the auto configuration and the component scanning to exactly that, to that package. Right? So let's see how this goes. If we look at the catalog module, the catalog integration test. So you see we have a test case here. That's a Spring Boot test. Right? I can just pull this up a bit more. And I'm going to replace that. Bear with me, forget about the verify automatically false. I get to that in a second. But what that does is I can now run the test. Can I? Run as JUnit test. Go ahead, and should a console pop up. And that should give me quite a bit of information. So the test is green, that's fine, it still works. And what has it done? And that's something like we paid particular attention to, because as soon as you start, okay, here's your application, but we actually we only run parts of it, then it's quite important for you to know about which parts you actually run. So there's quite a bit of log output that is it in info level? So basically saying, okay, we bootstrap that module for catalog, standalone mode. I go into different Bootstrap modes in a second. It's using that base package. There's no module dependencies. That's a good starter maybe. The test Bootstrap basically goes ahead and analyzes your Spring Beans and your package structure and finds out about module dependencies. So for the order, if we go on later to the order test, it will find out that the module has dependencies on other modules and by which beans those dependencies are actually caused. Right? So you find a public bean of catalog, type catalog, that's a Spring Data repository actually, and there's also support for including other modules no matter whether they are actually dependent on explicitly or not. The thing is that you might have, like in this case, like here, the support package. There's some general infrastructure components in there, some JPA converter, some it's Spring converter implementations that help us do certain things. Infrastructure, we always want to bootstrap them as well, and for us not having to actually explicitly declare that, there is a way to go ahead and say, okay, these are shared modules or these packages are shared modules. Please go ahead and bootstrap them. Same for the user account package, because literally everything is depending on that in that particular application. And the most important thing and the last thing here is basically this log statement. So we're getting information about like which packages the auto configuration entity scan packages are reconfigured to, right? And this exactly, I mean, there's the thing. I'm basically showing you that there's nothing to see here, right? So it's just doing what it's done before. It's just like has not bootstrapped like any other module. It hasn't bootstrapped the accountancy, the order. So it doesn't need, Hibernate might start up a bit faster because it doesn't have to scan for entities and all those packages and what have you. And oh yeah, that worked pretty well and is pretty simple because the catalog module itself didn't have any other module to depend on in the first place, right? Remember that. I get back to that in a second. To better be able to show you a couple of other features of Moduliths, I deliberately created an architectural violation here with an additional commit. Is anyone able to spot that architectural violation? There's a cyclic dependency, right? So there is this one here. And that comes from the fact, like as I said, I deliberately broke it. So there is some code in there that when an order completes, or it's basically is completed, then there's an active call to the inventory saying, for this order, please update in the inventory. So whenever I order 2 TVs, then like there's got to be an inventory update so that there's like 2 TVs less in the inventory, right? So symbolizing that. The method is declared in a way that it takes the order as an argument. So there is that's why it's a type dependency only. There you basically have the inventory takes the order, and the order has to know the inventory to actually invoke the method. So there's some cycle here. And the first thing we have, I mean, that's an architectural violation, right? So actually, Modulith should help us finding that. And that's the problem. And let me show you how it actually does that. There's the inventory test. Yada, yada, yada. I'm a bit puzzled that that's still green. Oh wait, I have to check. That's the thing. 1 sec. That's when you basically try the demos and then set everything back and then write. This one. Let's refresh real quick. Right, there we go. So what you see here, I had the very same flag that I used before, and I asked you to not ask me about it. What add-module test actually does, it applies, like for every test run, it actually applies a couple of verifications onto your monolithic structure. And one of those checks that actually runs out of the box is a circular dependency check between modules. Right? So while it's fine that, like, even if you have sub-packages in your modules and you might introduce cycles there, Modulith doesn't care about those, but on the module level, it actually does so. And if I remove that, I get into the extra includes in a second. So you see the test cases are failing, and we get the cycle detected. So it basically says down here that the inventory has a cyclic dependency. You cannot actually mark that. That's fun. So the inventory depends on the order, and the order depends on the inventory, right? I'm not going to go ahead into how we actually remove or resolve that cycle. Again, that's part of the other talk I recommended already. Not into the details. What we actually do is we introduce event-based notification for the inventory. So instead of calling the inventory directly, we just produce a Spring application event and let the inventory basically listen to that. So we're not using any kind of messaging infrastructure here. It's all JVM internal Spring application events. Again, not more details on that, other than the fact that what we've done here is we've basically replaced an explicit component dependency, so something that we had to auto-wire into the orders module, with the publication of an event, right? And that's a good idea in the first place. So every time you find yourself, let's say you look at your code base and basically try to look at it in the same way that I do here, whenever there's a dependency, just like the one that I have to the business time module, get to that in a second, ask yourself, can you replace that with that kind of event publication mechanism? Because that every dependency that you have to another module is a dependency that you have to sort of create or bootstrap when you're actually trying to test the module, right? And the less you have of those, the better, right? So always, that's some mantra of mine, actually, I always try to avoid the problem before I actually try to solve a problem, right? So, different types of dependencies between the modules. Simple type dependencies, for example, let's say we have the order has line items, and the line items refer to a product in the catalog module, right? Not too much of a problem, actually, because like Hibernate knows, or fortunately knows how to bootstrap, like it analyzes the types and would bootstrap them as well. But for the actual Spring Boot application context start, it doesn't actually matter too much, right? Component dependencies, basically everything that you hand into constructors of Spring Beans or auto-wire through other means. Oh yeah, field injection, by the way, is by default rejected by Modulith as well. It's recommended to use a constructor injection anyway, right? So component dependencies, and there's another kind of dependency which sort of is a simple type dependency as well. If you have event listeners in your, let's say, inventory module to listen for the order created event, then you have a dependency in that direction as well. I've just listed them in a separate dependency type, as the direction sort of is kind of inverted, right? So the yeah, basically, that's the thing. Avoid those. That was the part of the story. So avoid component dependencies. So what about the cases where we can't avoid the dependency, just with the business time, right? So our module has a dependency on other modules. And what does a bootstrap look like, and what does a failing bootstrap look like? That's what I tried to start in the first place. So let's start with that's the abstract integration test. It's just a standard Spring Boot test, yada thing, just with an intermediate of that class. So let's see. We remove that. So we basically remove the add Spring Boot test application, and we go ahead and just use add module test. Again, ignore the extra includes for now. So I run this, and I'm presented with an error. And that error, oh yeah, geez, I have to check out the fixed. Git check out spring-io. Yep. Refresh. So that's basically the next commit that fixes that circular dependencies problem, and then I have to redo what I just did. This and that. That should work now. So we've removed the package cycle, but you see we still get a lot of like failed tests. And why is that? It's pretty telling, because like the exception says, where is it? No qualifying bean of type business time, right? See that down here? And so what we basically face now is the fact that persistent order manager, the component persistent order manager has a dependency on that business time component. It's basically, to just give you a bit more context, it's a component that sort of abstracts now in the application, because the students have to sort of, for their presentations, they sort of have to demo the application and kind of fake that it's either like 3 months earlier or 3 months later. So we sort of, to make it easy for them to work with that kind of aspect, there's something called business time, and it basically gives you just gives you now, right? So what is it? And then they are able to basically postpone, add 3 months to the current time or whatnot. So an external dependency order repository is just an internal module dependency, right? And it's kind of interesting actually here, because just from looking at that and the fact that there's basically from that annotation over here, there's a constructor being created, taking a business time and taking an order repository, it's not immediately obvious that these different different dependencies come from different modules, right? So you don't really see that on first glance. So what you do here to solve that problem, or one possibility to solve that problem, is using Spring Boot's capability of adding mock beans. For those of you who don't know, you just put that add mock bean annotation, declare an add business time in here, and Spring Boot will now go ahead and bootstrap the application context. Adding a business time mock bean to the application context. So you see its green again, and what I kind of like about this idea, I mean, it's a bit lost through that kind of like having to pull up the font size so much, but you actually get a test that says add module test, and you say add mock bean. So you're kind of describing that I want to test the orders module, and the orders module has some required dependencies outside its own scope, and the ones that we need are exactly those. Let's say there's like 2 or 3 components, and it's a very clear description of what are the actual external dependencies of that particular module. The extra includes here is just basically you can define module names that you want to include in the bootstrap of that test. I've mentioned shared modules before, but this thing here is I just like pull it in because I want to use the catalog to actually create some products in my test case. I could have gone ahead and just used, let's say, the data.sql file, or use any kind of other data initialization technology to do that. It's just very convenient here, and extra includes allows me to do that. Right, so mockbean for kind of, well, I hate to say it that way, but kind of unit testing. So it's still integration testing the order module in isolation, right? The other thing that you could do, you could say, okay, why not just bootstrap the direct dependencies of that particular module as well, right? And that's where bootstrap modes come into play. You can use that annotate or that enum here inside the add module test annotation, and just run the test now. That's kind of, again, the module bootstrap basically creates a module graph, or a graph of the modules involved, knows that, where was the console here? Try to find. You see that pretty explicitly in the output. It says, okay, we want to start sales put order with direct dependencies. Sorry for that. Here are the beans in there. You see order manager is a public Spring Bean. Order repository is protected, package protected. Persistent order manager is also package protected. And then we include the dependencies user account, time, because we say we had, there should be actually, yeah, direct module dependencies. You see that user account and org Spring SizePoint framework time, right? So we found out about those, and as we said, direct dependencies are supposed to be included. It's actually run here as well. So a pretty flexible arrangement. There's a third way of bootstrapping the module test, which is all dependencies, which from the entire module graph just picks the one as an entry point, the one that you're kind of running, orders right now, and it would just bootstrap all the dependents and dependents of the dependents, basically. Right, so it's just the entire subgraph of the dependencies. That should work as well. Does it? Looks like this. Okay. All right. What time is it? 34. Pretty good. This way. Bootstrap modes. Just for reference, right? Mockbean as a standard Spring Boot mechanism. There's nothing that Modulith actually customizes about this. And the other two are basically just like including different modules. So this is the test support, basically allowing you to test individual modules. There's also, as I said, the tests already include some verifications. circular dependencies, you can also explicitly define which other modules a module is allowed to interact with. And then if you do so, then like any other dependencies will cause a failure. There's API in Monoliths that you can use to run the tests individually. That should be somewhere in here, right? So you can, again, you just write a test. It's not, let's say, bootstrapping the application context. It just sets up the Monolith infrastructure. It just takes the sales point sample, in this case, the application class, and then you call verify on it. It just like verifies all the rules that I've just like mentioned. There's probably going to be API in the future where you can ask, for example, if you still want to use field injection to not actually bark at you because of that. Right, so this is kind of just an API. You can just also run this in a main method or what have you. The entire verification and analysis of the packages is built using a tool called ArcUnit. Has anyone heard of ArcUnit before? It's basically a DSL to describe, okay, these types that qualify through a naming convention, through an annotation or what have you, are allowed to refer to other types, not allowed to refer to other types. So you can basically write code to describe rules. And Modulith is, like, in a nutshell, it's nothing more than an annotation-driven way and convention-driven way of applying some predefined rules. And if you have Modulith on a class path, you automatically get ArcUnit on your class path, and you could easily extend that to include these additional rules in those runs. All right. Before we move on to something like to the last point, a kind of or kind of detour basically into slightly more complicated package arrangements, right? So far it's already been pretty simple. So we have like packages per module. We could use package scope to actually avoid other components to be referable in modules we don't want them to be referred. But there might be situations where you want to, let's say, create sub-packages of these modules, right? And then that sort of forces you, and that's the reason I try to avoid that, that forces you to make like types public just to be able to see them from their sibling package, but then it also makes them public to the entire application. And there's a couple of additional features in Modulith in the verifications that come in handy here. So just to get you started with some conventions that I'm going to use at the following slides. So there's like green medals for we allow something, and red medals for we reject something, and that 0110 thing is the compiler, and that M thing is Modulith, right? And color codes: green bounded context, Java package, public, package protected. You'll see that in a bit. So we've seen that. Everything, just to give you an idea of where we're coming from. Simple package, you can have a public type, and you have a package protected type. You have the same in a different module, and you can refer to the public type from the other package, and the compiler thinks that's okay, right? That's Java 101. Nothing to see here. It also rejects the access of the package protected component in the other type. Again, that's something that students should even know, right? Just to pick you up. However, if you start introducing like sub-packages for that, sub-packages, it kind of raises the question: what happens to public types or in these packages? And the idea we follow here, let me unfold that. So yeah, I'm getting ahead of myself. Still, the first rule still applies. We can refer to public types. That's okay. Package protected types in nested types cannot be referred to because package protection is disallowed by the compiler. However, if there is a package that contains a public type, that would be referable, right, by the compiler. And if you, let's say, have worked in, for example, if you had to work with OSGI or something, or even with Jigsaw, these days, there's some kind of convention that has sort of established, which is that it's usually like one package that contains publicly referable types or externally referable types. And that's what Modulith is doing out of the box without you having to define any kind of additional metadata. So without doing anything else, that would be overruled by Modulith. So if you run this kind of Modulith code with .verify, you'd get like dependencies to public types in subpackages of the actual module package rejected, right? So long story short, with Modulith, you basically get like your module package back, everything in subpackages, even if public is not accessible to other modules. Right? So the actual module package becomes the API package, basically. In the interest of time, let's skip that module. It's probably something worth exploring if you're actually running into the multiple packages thing in the first place anyway. The last thing, and before we actually come to the discussion of how does that compare to other approaches already available, is documentation support. I'm quite a big fan of Simon Brown's Structurizer library. I mean, we're sort of sharing some opinions on the way that Modulith should be structured in the first place. But as I realized, okay, we sort of have to get at runtime, we have to get to a model of the structure of your code base anyway. Why not just use that to create some documentation that's actually that sort of represents what we have there, right? So represents the is architecture rather than like booting up PowerPoint and then putting rectangles on it and then hoping that might fit to what the code actually has, right? So there is, and you've probably already spotted that before, there is a component called Documenter that you can just like use and hand the modules thing in. There's a couple of options you can place here. I don't want to go into details because it gets like pretty edge casey from time to time. But you can basically have options to define what ends up on the diagram basically, and then there's like two major modes, which one of them being okay. Documenter, please go ahead and like give me a plant UML component diagram for the modules that I have in my application, or for a particular module, render all the outgoing dependencies, right? Which is kind of helpful if you want to just like create documentation that, okay, here's my order module, and to understand the order module, you be sure you have understood the other modules first. I actually thought I wouldn't need any internet access, but let's see if that works. Try to find the SalesPoint reference documentation. Yep, to just show you the outcome of this thing. What's happening here, before we start with that, what's happening here is that we create plant UML files in, if I run this test, we create, similar to what Spring REST Docs does, it's kind of, it's generating in target, where is it? Generated sources, there's probably generated docs, Modulith. So it generates, I'll zoom in for you, it generates the components.uml file, which is a plant UML file, and the module dash yada 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 thing for each of the modules individually. And then the outcome of this is something like this, right? So it's basically showing you there's probably a bit of optimizations that we can do regarding the layout, but it's actually the full picture of entire SalesPoint here. The different dependency types, and that's actually the reason why, one of the reasons I mentioned them so explicitly, are make it into the diagram as well. So you see the inventory is actually listening to the order module, and then there's uses in terms of this is a Spring component dependency, right? So we're actually using the other module, and depends on is basically just the raw type dependency, right? From order to product, from the line item kind of thing. You can, of course, have options there to create, okay, just give me the diagram with all the listens to relationships, and then you just see like all the eventing going on and what have you. And for, yeah, that's probably quite helpful here. For the inventory module, basically that's the single module view basically that you get out of this. So what I'm kind of doing here is I let the test generate the plant UML diagrams. From my actual reference documentation, I just include the diagrams, and then when the documentation is rendered in the build process, then that is kind of just included in SVG format in this case. All right, so how does that compare to alternative approaches? So one of the things that I was kind of thinking about in the course of developing that stuff is, as a developer, I'm kind of the faster I get feedback about potential violations, architectural violations, the better, right? And that's the reason why I'm so like kind of preaching almost the use of the package scope, right? If I can get my compiler to actually reject a referral to a different type in a different package, that's basically the best. It can't get any faster than that, right? The next kind of, like, I always measure it in the distance from my actual coding exercise. The compiler is with my coding exercise. So I type, and at least in Eclipse, everything is just like compiled right away. And the next distant thing I can do is run a test, right? That's why we're kind of like focusing on the verification in test cases. And there's also, of course, value in running additional checks in a build process, but they are usually not executed as frequently and sort of farther away from my actual like type save iterations, right? And that plays into a lot of these considerations here. So the first thing I usually get asked is, why don't you just do additional artifacts or multiple artifacts for each of these modules? Because then that dependency problem sort of goes away, because both Gradle and Maven don't actually allow you to create cyclic dependencies. Well, that's right, and you can actually do that. Modulith doesn't care about like which jar, which part of the code base is in. We're just inspecting class path, right? We're running on the class path. However, as you see here, this project, that's a single Maven module project, and let's say accountancy is a handful of classes. Catalog is just like 3 classes, right? Why on earth would I go ahead and split this thing up into 15 Maven modules and then deal with 15 POMs and basically have all my dependency management like spread around in this if I can just like leave it like this, right? Again, there's nothing wrong with doing that. It's just it might just not be like the benefit and effort ratio might just be not as balanced. The other thing being, as I like in the test execution, I was able to like run that module in an isolated fashion. I was able to run it with the entire subtree of modules, with the dependencies solidly governed by Maven modules. You don't actually get that, right? You still need something that gives you the flexibility of like what do I want to bootstrap in the application test run or in the module test run. Right, dedicated control of dependencies. On the plus side, test scope is defined by the artifact is a positive thing. I think I mentioned that as a negative thing as well. Potential explosion of number of artifacts. I've seen projects doing that. They end up with, I've been involved in projects that ended up with 50 or more Maven modules for something like that, which is kind of, yeah, it sort of works. It's still a bit, I think, adding a lot of complexity that if you can avoid it and it doesn't actually give you more than that, and it's fine. What I also think is, I think that's the last bullet point, right? What this kind of does is it sort of makes the internal structure of that monolith visible to the outside, so that now someone who wants to use that thing, right? How does he or she actually know which of the modules he or she has to assemble to actually get that thing to do something meaningful, right? And with that single jar, okay, just take that, right, and include that and run it. Java module system, JPMS, pretty new on, well, in Java terms, pretty new. Is anyone already on Java 9? Who's on Java 9 or better? Okay, so for you 5 guys, that could, I mean, it's theoretically it is an option. It's still I'm a bit surprised to see so many people that think that the Java module system is a good idea to actually structure your application. Because it wasn't designed to do that. It was designed to modularize the JDK, and you can see that like every time I've had a look at it and tried to apply it to one of the projects I've seen, it's kind of like failed because of it just not thinking about problems that you have in those applications, right? Just the fact that a jar, one module, one jar, right? There's this kind of relationship. There's no way to have multiple modules inside a jar. So you're basically back to this multiple Maven module thing. That's kind of like already very invasive, as I think, right? It just wouldn't work. It wouldn't allow me to do the architectural management I do with the sales point thing, unless I actually decide to split it up into multiple artifacts, right? There's the semantics of the opens keyword. I don't want to get lost in this because there's so few people for which it actually would have been an option. The opens keyword is about reflection, and the thing I see critical here is that the incentives that it actually creates to like assemble all the types that need reflection into a particular package, and that's kind of I think a weird way of thinking about Java packages. And yeah, there's no way you actually like dynamically assemble stuff for tests, just like I mentioned before with the Maven modules, right? So your dependency set is fixed at some point, and there's no flexibility beyond that. Still, if you want to use it, it's just fine. It doesn't in any way collide with Moduliths, right? And there's a couple of external tools still, that like external in the regards of additional things you can do include in your build if you want to. They are very powerful. Things like JQ Assistant actually go ahead and take your code base and analyze it and take the AST, put that into a Neo4j graph database, and then allow you to define queries on those graphs to detect violations. It's like insanely powerful because you can not only include Java code, but also like your Git commit history or what have you. You can find, in the last 10 commits, they all touched one particular class, and given a certain threshold, you want to report that, right? Because you realize that this class might have like too much responsibility because it's changed by every time. But this is like more advanced structural analytics, and they are mostly included in build processes. And as I said, they are much farther away than to the typical code hack run tests cycle. All right, to recap, Moduliths is package conventions, customizable package conventions, so you can sort of soften those restrictions using the @module annotation on the package info class. So there's a couple of things you can do there. Dedicated test support for Spring Boot, and access rules, as well as the documentation support, the is documentation support. A couple of additional resources. There's the project website. I mean, you're welcome to ask for additional features. I've been talking to people that were like asking me about, what about database migrations, right? If you have database migrations, can you have something like flyway migrations per module? Right now you can't. It doesn't work. But I talked to Axel, and we're working on that. His talk. Axel Fontaine is the guy behind Flyway, and the second talk, Majestic Modular Monoliths, basically going into arguing why a modular monolith might be a good idea in the first place for you to start your project. Simon Brown's talk on that, and as I mentioned, the refactoring to a system of systems one, right? So to basically close down here, the reason I think that starting with a monolith and packaging multiple bounded contexts into a single deployment unit might be just a good way for you to start quicker, to be able to refactor things quicker, and the monolith itself basically causes you to keep that structure in the monolith, so that in case you realize, okay, one of these three modules needs different scaling characteristics, right? Because it's read the catalog. Let's say we have to externalize the catalog, then you'll be much likelier to actually extract that quickly if you've have something like Modulith in place. It doesn't have to be that in the first place. There's other tools as well. Just starting slightly more monolithic, but being prepared to split things up is kind of a very decent way, I think, to like new greenfield projects, especially if you're not like entirely sure about the domain boundaries or the bounded context boundaries in the first place. And with that, we have a couple more minutes. Are there any questions? Thank you in the first place. Any questions? You here.
You talked about the negativity of circular dependencies.
Yeah.
So if you actually have microservices that are deployed independently, they can actually talk back and forth with each other.
Yeah.
That circular dependency. So that doesn't seem like a showstopper to this.
Okay. The question being, as I frowned upon circular dependencies here, with microservices, it's quite often the case that they sort of form circular dependencies, because one is publishing an event that the other one reacts to, which then publishes an event that the first one reacts to again. One thing is that the timing aspect is a topic in that, so that basically if you're working with events, then that sort of gets slightly softened, that problem, because you decouple the systems by time, not necessarily by business knowledge, but at least the other system doesn't have to be there at the point when the other one wants to publish the event. The other thing being is that you still have the same logical problem, which is, I mean, what is the problem with the cyclic dependency, right? As long as you don't have to, I mean, has anyone ever been bitten by a cyclic dependency? Why was it a problematic thing? The problem I see is that let's say start with a non-cyclic dependency, right? We have this module A and it depends on module B, and module B doesn't depend on A. If I have a scenario like that, I can change module A at will. I can do whatever I want to it, and I, by definition, know I'm not going to break anything in B, right? And that totally breaks as soon as I introduce the dependency in the other way around. So it might be still fine, or it might be possible that I can basically change things about module A, but as soon as there is like the cyclic dependency, there is a much bigger risk of change, basically, because if I change things in one of the modules, I always have to sort of be aware that I don't break anything in the other module. And also, modules that only have outgoing dependencies can usually very easily be pulled out of the deployment context, right? I could, like, say for the inventory system, for example, that's listening to order created or order completed events. So if I decided to move those out, I just go ahead and say, okay, instead of listening to that order completed event in my JVM, I just write the listener that puts that thing on a Kafka or something, and then I pull that I can literally grab that package and move that to a different deployment unit, and then deploy that separately, right? So I'm kind of like putting, there's a German word for that, but I'm putting spots in my, and it's long, I'm putting spots into my code base that I want to be able to break it apart easily, right? Sollbruchstelle for the German guys. I'm not sure there's an English one for that, but you should, just like kindergarten, put Sollbruchstelle into your vocabulary. That makes you sound clever. Yeah, that's it. So it's slightly softened the problem in a microservices world, and oftentimes you're not even like necessarily realizing, right? Oh, I just listened to that event and I'm producing events, but like the recipient and the sender is the same entity. It's not even, you might not even be aware of. And if you then have to change things about like business rules or what have you, that just gets worse, right? So, right. Another question. If not, I've got to run pretty quick, unfortunately, because I have a customer meeting coming up. But I'll be around like all day tomorrow. I'm the short guy with the hat. Have fun at the conference, and thanks for your attention.